Have you ever wondered how your email service is so good at filtering out spam messages? Well, the secret lies in the power of machine learning. Spam messages are not just annoying. They take up memory space, consume computing power, and slow down speed. To top it off, it's a time-consuming task to manually sift through and remove these unwanted emails. That's where spam filtering techniques come in, helping us save time and resources. Two of the most effective machine learning models used for spam filtering are the Naïve Bayes classifier and the support vector machine. These models have been developed and fine-tuned over the years to efficiently separate legitimate messages from spam, ensuring your inbox stays clean and relevant. Intrigued? Great, because it's time to dive deeper and understand how these models work. Let's start with the Naïve Bayes classifier. This is a supervised machine learning algorithm that shines in classification problems. It's built upon Bayes' theorem, which is a fundamental concept in probability theory and statistics. However, the reason why it's called naive lies in its core assumption. The classifier assumes that all the features in a class are unrelated to each other. This assumption of conditional independence among predictors is what gives the Naïve Bayes classifier its name. Now let's break down how it works. Imagine we have two events, A and B. With Bayes' theorem, we can calculate the posterior probability of event B given event A has occurred, using the probabilities of event B and event A, and the probability of event A given event B. However, things get a little more complicated when we have more than one feature. In this case, calculating the posterior probability can become quite tricky, sometimes even leading to a zero probability problem. This is where the Naïve Bayes classifier comes to our rescue. By assuming conditional independence among predictors, it simplifies the calculation of the posterior probability significantly. For instance, if we have two predictors, x1 and x2, and a target y, we can calculate the posterior probability using the Naïve Bayes classifier. Essentially, the algorithm takes into account each predictor's contribution independently to estimate the target. That's Naïve Bayes in a nutshell. Now, onto our second model. Next up is the support vector machine, or SVM for short. The SVM is a supervised machine learning algorithm used for both regression and classification problems. What makes SVM fascinating is the way it visualizes data. Imagine a space with as many dimensions as the number of features in your data, and each data point plotted within this space. This is your n-dimensional space. Yes, it's a bit of a stretch for our three-dimensional thinking, but that's the beauty of mathematics. It can take us beyond our physical limitations. Now, the goal of SVM is to find a hyperplane within this n-dimensional space that best separates the different classes of data. Think of this hyperplane as a boundary line or a wall. In 3 dimensions, it would be a plane, and in 4 dimensions, it would be a hyperplane. The true magic of SVM lies in the selection of this hyperplane. It doesn't just pick any random hyperplane. It picks the one that provides the maximum margin between classes. The margin is the distance between the hyperplane and the nearest data point from either class. Maximizing this margin ensures that new data points are classified with a higher level of certainty. Now, you might be wondering, what are support vectors? Well, they are the data points that lie closest to the hyperplane and effectively support the position and orientation of the hyperplane. They are the critical elements of the data set. They define the decision boundary and influence the classification results. But SVM also acknowledges that the world isn't perfect. It allows for a soft margin, meaning it tolerates some data points falling into the margin or even on the wrong side of the hyperplane. It's a neat way of preventing overfitting and making the model more robust to outliers. So, that's a quick run-through of SVM. Now let's see how these models are implemented in Python. Now that we have a good grasp of the theory, it's time to see these models in action. The process of implementing Naïve Bayes and support vector machine in Python is quite straightforward thanks to the scikit-learn library. This library has made machine learning accessible to everyone by providing user-friendly interfaces for building models. First, we need to import the necessary libraries. This includes NumPy for numerical computations, Pandas for data manipulation, and scikit-learn for machine learning. From scikit-learn, we specifically need to import Naïve Bayes and SVM from the sklearn classifiers. Next, we load our dataset using pandas. Remember to thoroughly clean and pre-process your data before moving on. This might include removing unwanted columns, handling missing values, and converting categorical data into numerical data, among other steps. Once our data is ready, we split it into training and testing sets. This is crucial for evaluating the performance of our models later on. Scikit-learn provides a function called train_test_split for this purpose. We then create instances of our Naïve Bayes and SVM models. We train these models using our training data. The fit method is used to accomplish this. It adjusts the weights of our model based on the data it's been given. Finally, we use our trained models to make predictions on our testing data. We can then evaluate the performance of our models by comparing these predictions to the actual values. Scikit-learn provides several metrics for this, such as accuracy score, confusion matrix, and classification report. And that's how you implement these models in Python. Not too difficult, right? That's a wrap on Naïve Bayes and SVM. We've delved deep into the world of spam filtering, unraveling the intricate workings of the Naïve Bayes classifier and the support vector machine. We've seen how the Naïve Bayes classifier relies on the principle of conditional independence among predictors, and how the support vector machine uses hyperplanes to classify data. Importantly, we've also explored how these models can be implemented in Python to filter out those pesky spam messages. Now you know how your email service might be keeping your inbox spam-free. Pretty cool, isn't it?